Okay, welcome. Today we're going to look at solving exponential equations, so let's get your notes out and we'll get going on this. Remember, at any point in the video, if you're falling behind, to pause the video and get your notes caught back up. We need complete notes. If you didn't quite understand a piece of the solution, go ahead and rewind it and listen to it again. Sometimes it takes 2 or 3 times through to understand the concept. If you still have questions, write them down and we will answer them in class. So let's go ahead and get going. All right, we're going to be working out a 7.6, solve exponential and logarithmic equations. So if you need more examples and want to read about it a little more, go to 7.6 in your text. We've already read about Newton's law of cooling, the relevance piece. We've already talked about this in a previous lesson. We've gone through the vocabulary, and we've talked about the change of base. We're going to focus a little bit on the equality property. We have used this before as we went evaluating. We were evaluating. We did use the equality property. We're going to go over it again to make sure because this is the basis of what we're going to do or use to solve. All right, the equality property simply says if b is a positive number other than 1, then b to the x is equal to b to the y, if and only if x is equal to y. Essentially what that's saying is that if my bases are the same, in this case 3 and 3, and we're equal, so bases are the same and we're equal, this implies that the exponents are equal as well. So 3 to the x is equal to 3 to the 5th, bases are the same, they're equal, x has to be 5. It's equality. I mean, the left side has to equal the right side, x has to be 5. So again, if the bases are the same and they're equal, the exponents must also be. All right, let's go ahead and apply that to an example. So here's our concept, and this is how we're going to do it. So we're going to approach all our problems. It basically says to solve exponential equations, we will first try to use equality property. We have another method, but we first need to see if equality works. So we will first try to use the equality property. We will simply try to rewrite the equation so both sides have the same base. So our first step is, can I rewrite both sides to the same base? All right, if this can't be done, then we have to use our other method, which is solving by logarithms, which we will not cover in this video. So let's go ahead and look at an example. All right, so our first example is 4 to the x power is equal to 1/2 to the power of x minus 3, and we need to solve this. So let's go ahead and see if we can use our equality property. It first says, can I rewrite the bases to the same base? I have a 4 and a 1/2. These both can be written to a base of 2. 4 can be written as 2 squared. So I'm going to go ahead and put some parentheses around that to say, hey, that was my 4. And I'm going to bring the exponent down, which is simply x. That's equal to, let's put another set of parentheses for the 1/2. Now I'm going to write this 1/2 in the base of 2 using a negative exponent. So this is 2 to the negative 1. And bring down its exponent, which is the expression, so I'm going to use parentheses, it's a binomial, x minus 3. Alright, so I've now written these to the same base. I want to do some quick simplification using the power property. 2 squared to the x power, we multiply the exponents. This is 2 to the 2x power, and that's equal to, same thing over here, 2 multiply. Now this is -1 times a binomial, so that's negative parentheses x minus 3, or negative times the expression x minus 3. We can't forget to distribute through the negative. We've got to make sure that negative gets distributed through on both of these. So with one more quick simplification, the left side stays the same. The right side becomes 2 to the power of negative x plus 3, because I distribute through the negative. Now I've rewritten my equation to the same base. They both have a base of 2. So by the equality property, so I'm going to move up here, I write the EQ property. So I'm going to use my equality property right here. I can say because the bases are the same and they're equal, that the exponents must be the same. So I can say 2x has to be the same as or equal to negative, bad negative sign, negative x plus 3. Now we have simply a linear equation, so in 2 steps I'll have this thing solved. So I'm going to add x to both sides. So this is 3x. He's gone. I'm left with 3, divide by 3. So the solution to our equation, or the value of x, is simply x is equal to 1. Okay, that's all this is. This is using exponent properties and equality. And if you have any more notes, remember, or any questions, write some notes down on the side. We'll answer them in class. And if you didn't quite get one of the pieces, go ahead and pause the video and listen to it again. Okay, let's kind of move on. I'm going to have you try to solve this one on your own. So go ahead and pause the video and see if you can solve this. And when you're done, turn the video back on, and then I will do the solution for you. So go ahead and try one on your own, and then check it to mine and see if you have it. So let's go ahead and do that right now, please. Okay, hopefully you have a good solution here. I'm going to go ahead and work it through just to make sure. Okay, so we need to solve 3 to the x power, or solve for x. We have 3 to the x power is equal to 1 over 9 to the x plus 3 power. So we simply want to try first to rewrite these to the same base. 3 cannot be written to any other base but 3. But 1/9 can be written to a power of 3. So while my left side is going to stay the same, so the left side is going to be 3x. The right side, however, can be written using a negative exponent to 3 to the negative 2 power. 3 squared is 9, and negative will take the fraction away, so those are equivalent. And the exponent comes straight down. Oh, it's supposed to be black, didn't change color. That's okay though. Okay, left side stays the same. He is still 3x. The right side, however, we can do the power property, and we can multiply in that negative 2, so this becomes 3 to the negative 2x minus 6 power. We now have bases that are the same. It's equal. This implies using our equality property. Again, I'll write EQ for equality prop, that x, for the exponents, is equal to negative 2x minus 6. This is just a simple linear equation we know how to solve. So I'm simply going to add 2x, or isolate the x, add 2x to both sides. I get 3x is equal to negative 6. Divide through by 3. I get x is equal to negative 2. And there's our solution. Okay, again, if you have any questions, remember, write them down. We'll answer them in class. Thank you.